Welcome to this episode of eTech. Today we're going to take a look at a Florida export. No, we're not talking about oranges. We are looking at the Stateline Wind Energy Center, or at least the edge of it. It's a very quiet day today, none of the turbines are turning. But this particular wind farm is actually owned by Florida Power and Light. It's near Touche, Washington, and that is how you pronounce it. I know it's spelled Touche, near Walla Walla. We're just on the south side of the Snake River here, and let's take a look at some of these turbines and to see how much power they can create and contribute to the electrical grid.
The Stateline Wind Energy Center, which is owned and operated by Florida Power and Light, is located on Vansicle Ridge. It is a crest of land that straddles the Washington and Oregon border near Touche, Washington and Pendleton, Oregon. This ridge catches winds that are funneled west to east through the Columbia Gorge. And though it can really blow on this ridge, wind speeds average 16 to 18 miles per hour. It's 25 to 29 kilometers per hour. And that is really the perfect range for these large turbines. As you can see, the area around the project is used mostly for dry wheat farming and the grazing of livestock. The current site was able to make good use of pre-existing transmission lines. These were already in place due to the proximity of power-producing dams on the Snake and Columbia rivers. Look for a video real soon featuring these. Now, planned for a total of 456 turbines, only 186 are currently operating in both Washington and Oregon. Proposed expansions would make this the largest single wind farm in the world. The project employs 660 kilowatt capacity Vestas wind turbines, and these collectively could produce a maximum output of about 307 megawatts. The current operating capacity is around 123 megawatts, and on average the project is expected to produce about 30 to 35% of that capacity year-round. As we mentioned before, the average wind speed is not necessarily the wind speed that we have. Look around you today, and there's hardly any wind. The turbines are controlled individually by electronic systems, and these direct the turbine into the wind. They adjust the pitch of the blades so that electrical production is maximized at any wind speed ranging from 7 to 56 miles per hour. It's 11 kilometers per hour to 90 kilometers per hour. What if there's too much wind? Well, these turbines are designed to automatically shut down wind speeds in excess of 56 miles per hour, or 90 kilometers an hour. That even allows them to withstand hurricane-force winds. The wind turbines themselves are grouped together in bunches or strings of between 5 and 37 turbines. And each turbine is spaced about 250 feet or 76 meters from the next one, generally slightly downwind of the crest of various ridges that overlook the Columbia Valley. Each of these turbine towers has a hub height of 164 or 207 feet. That's 50 or 63 meters. And the blades themselves are 76 feet long. That's 23 meters. One of the concerns with wind farms and wind turbines is the effect on wildlife. Environmental impact studies that were done at this location determined that this particular site was not used extensively by birds or other species that are vulnerable to injury from the turbines. And the turbine tower's construction, along with the use of underground power lines, was designed to minimize perching places for birds. As we've noticed in some of our other videos, most electrical power is produced by the interaction of a rotating magnetic field and a set of windings. Wind turbines are no different. Look for 2 more videos coming soon, one of them featuring doubly fed inverter generators. In a normal generator, the frequency depends on the rotational speed of the shaft. So, how does a wind turbine provide an output of 60 Hertz or 60 cycles per second? That's no easy feat if the wind speed keeps changing. So stay tuned to find out about that. The other video will feature a teardown view of a small generator and also look at the principles of power production. As always, thanks for watching, And if these videos are of help to you, please tell others and subscribe yourself.